So, getting into more actual calculations as far as looking at and analyzing statistical data, we're going to start with our measures of center, measures of central tendency. These things tell us what is typical, what is to be expected within a data set. The most common ways that we measure central tendency are the mean, the median, and the mode. Hopefully you've heard and seen these before. Now, how the mean, median, and mode represent center can vary widely based on the type of data we have and how that data is distributed. We'll go into more detail about that distribution in the next section when we're looking at measures of variation. And then we'll even break that data up into subsets when we look at measures of position. So our first and most common is our mean. Okay, that's usually what people think of with average. Most common, the sum of all the data entries is divided by the number of data entries that we have. We have two different types of mean. We have a population mean and a sample mean. They're differentiated based on, and it tells us, do I have a true mean of everything on my population, or is this mean based on a sample? And so when we find a mean based on a sample, there's usually a margin of error attached to it because the sample mean will change and fluctuate a little bit based on your sample. Okay, as your sample mean will change. So we use the Greek letter mu to represent the population mean. Sigma x, that's the sum of all of our data values, divided by population. A big N represents the population. Little n represents a sample. And so our sample mean is x bar equals the sum of all the data values divided by the sample size. So our population mean versus our sample mean. So when we are looking at finding mean, we have an example of weights for a sample of adults before starting a weight loss study. And we want to find the mean weight. Okay? So first, am I going to have a population or a sample mean? What tells me that's going to be a sample mean? It says sample, right? It is a sample of adults. Okay? So what's the first thing I need to find in order to get my sample mean? Add them all up. What's our sum? The sum of all of our data values. Okay? And what is our sample size? So what's our mean? If we round to the nearest whole number. Okay? Remember, pay attention to rounding. Attention to rounding. But if we round to the nearest whole number, we get 259 or 258 points. Depends on what you're rounding to. Okay? So that's our mean. It's what we most commonly think of when we look at average. Median is the value that's in the middle once our data is ordered. It has to be put in order first from least to greatest, and it's whatever data we have in the middle. So we want to take our first data set, and we want to find our median. So we need to get it in order from least to greatest. So what number are we going to start with? And then after that, what's after 223? We have two of those. After that?
260.
After that?
270.
After that?
285.
After that?
290.
Don't break a sweat. Okay. What's our middle value? 268. So we want to find the number in the middle. Okay, with small data sets, we can kind of count and see visually where the middle is. If we have a larger data set, there's a little formula that we can use where it is n plus 1 divided by 2. That tells you what position is your middle number. And so if I have a sample size of 7, and I average my sample size with 1, I get a 4. That tells me that my median is the 4th number in the data set. First, second, third, 4th number in the data set, that's our median. Okay, it works better when it's very, very helpful when we have larger data sets. Instead of having to sit there and count and try and figure out where the middle is, we can quickly find where that midpoint is and just count to that value. Figure out where our middle number is going to be. Now, if we have our median, and one of our people in our sample changes their mind and decides they do not want to be part of the study. So they decide they don't want to be part of the study, and we get rid of the person that's 285 pounds. Now we don't have a sample size of 7 anymore, we have a sample size of 6. What is that going to do to our middle number? Okay, it's going to make it lower, it's going to change it. Okay, what else? My middle number was 268. What about now? Yeah. So right now I have 2 numbers in the middle. So my median is going to be in the middle of those. It's going to be our midpoint of those 2 numbers. So we'll average those 2 numbers. 235 plus 268 divided by 2. What's our new midpoint? Or I'm sorry, what's our new median? So if we have an even number in our sample size, then our median is very likely not going to be a value in our data set, but it's going to be a midpoint of 2 middle numbers. If we have an odd number in our sample size, we just find the middle number. That's our median. Last measure of center is our mode. Mode is the data entry that occurs with the most frequency, whichever one shows up the most. If no data entry is repeated, or they all repeat the same amount of times, then we have no mode. If 2 entries occur with the same greatest frequency, then we use each one as a mode, and we call that bimodal. We have 2 modes. We can actually have trimodal and beyond that, but once we get past bimodal, the mode becomes increasingly less useful, so we don't even really consider it at that point. So if I have 3 data entries that appear with the most frequency, it's very likely that we might as well have no mode rather than specify it as trimodal. So bimodal or just 1 mode, that will kind of take into consideration, but if we go beyond that, it's not really, it's becoming increasingly less useful. So when we use our original sample, what frequency or what data value has the highest frequency? 235. 235 shows up twice. Everything else shows up only once. So our mode is 235. When we're looking at qualitative data that we could represent in a frequency distribution, I see I have political parties, Democrat, Republican, Independent, and other. We can quickly identify the mode. Which category has the highest frequency? Democrat. So our mode is Democrat. Mode is often best used when we have qualitative data. If we have quantitative data, typically mean or median is going to be our best measure of center. But if I have qualitative data, Democrat, Republican, Independent, how do you find the median of those political parties? It doesn't make sense. You can't do that. How do I find the average of the political parties? I can't. It doesn't make sense. So mode is the measure of center that we can use with qualitative data. All three of them can be used with quantitative data. Now, they all have their advantages and disadvantages. And again, however the information is distributed will impact how good the measure of center is. So, for example, the average American is a 5'8" white male who makes about $80,000 a year. Does that describe any of you particularly well? Not really. Okay, half of you aren't even a man. Okay, half white. Half of you, actually I would say all of you, aren't making $80,000 a year. So it doesn't really describe the population well. So we have to be careful about using central tendency, but it is an important tool in the toolbox of trying to describe a data set and what is typical about it. So when we're comparing our different measures of center, they have advantages and disadvantages based on the data set. How does the data look? And this will become really, really important as we move into our measures of variation. When we're looking at how a data set is distributed, what a data set is talking about, these will have different advantages and disadvantages, and which one is better measured will vary from set to set. Mean is often the most reliable because it uses every data value. It takes every single point into consideration. It doesn't leave any of them out. Median only considers one or two numbers, the numbers in the middle. The other numbers have no impact on what the median is. Mode only considers the numbers that show the most often. Those numbers may or may not be in the middle. However, the mean can be very have a big disadvantage when we have outliers. Any data entry that is far removed from the other, something that is far away from typical. Mean's not going to be very effective there. Oftentimes, the mean is going to give us a number that's not in the data set. And sometimes that can cause problems when we're trying to make decisions and figure out what's typical, and we get something that's not in our data set. We have to make adjustments based off of that. Median is not going to be affected by outliers. So when we have data sets where that information is present, we have outliers, we want to use the median instead, because it's not going to be what we call skewed by those outliers. It can also give a value that's not in our data set, and we have to take that into consideration. It also does not consider the variance or the spread in the data because it's not considering every data. It's only considering 1 to 2. Mode is not necessarily going to be a measure of center. Just because it's my most frequent doesn't mean it's in the middle. There are often cases where we don't have a mode, or there are so many modes it doesn't help us at all. It doesn't make a difference. But the benefit of the mode is that it is the only one that can be used on qualitative data as well as quantitative data. So when we have qualitative data, mode is our only measure that we can use for central tendency. So I want to ask a question. A lot of times when we're looking at, if you look at job listings, if you look at industry information, salary and wages is usually reported as median. Median salary for a company, median household income. Why do you think in these cases we would use median rather than mean when reporting things such as income and earnings? Actually, more often than not, the mean would be higher. The median in that general industry or that general perspective tends to actually be lower than the mean. Yeah. Are people typically going to be homeless or billionaires? No. So when we're looking at income, there's a lot of places where there is a large disparity between minimum and maximum. And so when you look at 1% of our country owns 90-something% of our wealth, okay, everyone else is kind of stuck in a smaller cluster. If you look at a company with 20 employees making anywhere between $40,000 to $80,000 a year, and then you have a CEO of that company making $500,000, $750,000, $750,000 plus a year, the mean is going to be probably higher than what anyone else in the company is making other than CEO, because they're making so much more. So median gives us a better representation of what's going to be typical, because it's not affected by that one person who makes significantly more than everybody else. We're considering which measure of center is best. We have to look at the data as a whole and decide which one we're going to use. And oftentimes we'll find all of them and then do a comparison. So we have a sample of ages in a class, and we want to find all three measures of center. Identify if there's any outliers and decide which measure is probably going to be the best. So we look at mean, we look at median, and we look at mode. I could spell mode. Okay, go ahead, take a couple minutes and calculate the mean, the median, and the mode for this data set. Does anyone have our mean? Don't round it. 3.75. Okay, for our mean. What's our median? 21.5. What's our mode? 20. Okay, so we got our mean, our median, our mode. Do we have any outliers? 5. That is a very old person in that class. Good for them. But that is not an age close to everybody else. This age of the students. So it's not. I know. So, which measure of tendency is going to be best? Why? Okay, but neither is the mode. So why would we want to pick median over the mode? Why would we might want to pick median over mode? We already discussed that.
Yeah.
tell me why mode is our best measure of center.
Because it's like pretty much like around the same age as everyone else.
It's close to the other ages. Yes, ma'am.
I think it would be medium because it doesn't take into account the 65, especially when it's asking like what's the measure of central tendency that best describes a typical entry of the status set.
That's true. Both of those don't take into account.
Varies.
Both of those don't take into account that 65. So both of those are not affected by the outlier. Why is median better than mode? They're close together. Why is median better than mode?
It's more representative of all the entries
How so?
There's one everywhere.
because mode is just how many 20-year-olds. It's
You're,
not the
you're so close. You are so very close. What's special about the number 20? It's the lowest number. It's not the center. It's the most frequent, but it's not the center. So if we're looking at the best measure of center, we're going to want something that's closer to the center. Mode is not affected by outlier. It is our most common, which has its place, is important, but median is closer to the middle. Now, a lot of stuff was thrown off about the outlier, okay? Well, let's recalculate mean, median, mode without the outlier. Our mean, instead of being 475 divided by 20, becomes 410 divided by 19. We take the 65 out of our sum, and then we divide by 19 instead of 20. What's our new mean? Twenty-one point what? 21.7, 21.6, 6. Okay. What's our new median? 21. Does our mode change? Mode doesn't change. So when we take out the outlier, what happens with our new measures of center? They're all a lot closer. So they're not as skewed. And when we see that once we remove that outlier, they all start to converge around 21, we see that, yeah, median is going to be the best measure of center in this case because it is closer to the middle and it is less affected by the outlier. It was still affected by the outlier. It still brought the median up a little bit, but it wasn't as largely impacted. And we can see that in our chart. When we look at all of the data displayed on a histogram, we can see our mode here, highest frequency, but it's not towards the middle. It's our minimum value. Our middle is somewhere over here. And so we have that median located there, but because of this big old outlier, our mean got pulled to the right. It's close to our middle, but it's not the best measure of the middle because of the existence of that outlier. And we're going to have a more formal way of identifying outliers in the end of the chapter as well. We also have weighted mean, where each value in the data set has a different weight or significant attached to it. And so it's very similar to a mean where we're dividing a sum over the number of entries, but now what we're doing is we have to take every data value and multiply it by its weight. When you take your courses in college, most college courses have 3 or 4 credit hours, depending on the course. All right? A lot of math and science courses are 4 credit hours, but most of them are 3. Okay? And so your grade in that class has a point value assigned to it, just like it does in high school for your GPA. A D is 1 point, a C is 2 points, a B is 3 points, and A is 4 points. And it's multiplied by the number of credit hours for that course. Well, then all of those totals are added up and then divided by the number of credit hours that you've taken, and that gives you your GPA. It's calculated the same way with all of your high school courses. Now, most of your classes are year-long, so that's 1 credit hour, but some electives are only half a year. And so those grades are multiplied by 0.5 because they're only weighted half. So when we want to find our GPA, we take the point value for each grade and we multiply it by the number of credit hours that it was earned for. So how many points is a C worth? 3 points? 2 points. 2 points times 3 credit hours. What do we get? We get 6. Okay? 6 points total. And then another C times 4 credit hours. How many points total? 8. How many points is a D worth? 1 times the 1 credit hour. An A is how many points? 4 times the 3 credit hours. We have another C. And how many points is a B worth? Times its 3 credit hours. So we have those totals, and then we add those all up. What do we get? The total of our point value. Total of our point value is 40, and we want to divide it by the total number of credit hours. How many credit hours do we have total? 16 credit hours. So our total points divided by our number of credit hours gives us a GPA of what? You divided that backwards. So 5. 2.5 GPA. Not great. Well, at least you're passing. So, when you go off to college, any of your courses that are 4 credit hours, okay, if you have a math lab, a science lab included with it, you're going to want to do really well in those classes because they count for more. Okay? An A in a 4 credit hour class is worth more than an A in a 3 credit hour class. Okay, so we have a weighted average. Your GPA here is a weighted average on a 4.0 scale. Mean of a frequency distribution. We can approximate and estimate the mean of a frequency distribution, but again, it is an estimate because we don't know the exact data values. So instead of finding the average using all the data values, we use the midpoint of each class and we multiply it by the frequency of that class. This is the same data set we used in section 1. So I went ahead and listed our midpoints again for each of those classes. And so what we're saying is, okay, I have 3 data values somewhere in this range. I don't know what they exactly are, so I'm just going to use the middle value of 172.5. I have 2 data values in my second class. I don't know what they are, so I'm just going to use the midpoint instead and get an estimate. And we're going to multiply those midpoints by the frequencies. So if I multiply my first class frequency by my first class midpoint, I get a total of what? First class midpoint by first class frequency. What do I get? 517.5. Okay? Do that for the next 6 classes and get your sum. Get your sum of your point values. You should have something in the 8,000s. So we multiply frequencies by our midpoints, we add them up, we get our total number of points, and then we want to divide that by our sample size. 860, 31 divided by 30. What is our approximate mean?
287.
Okay? That is our approximate mean. The actual mean, based on the original data set, was given 285.5. How does our estimate mean compare to the actual mean? More? By a lot? A little? Just a little bit. Should be close. The larger your class width, the more variation you can get. The smaller your class width, the less variation you're going to get when you're estimating your mean from a frequency distribution. Last thing I want to talk about is the shape of our distribution. We have 4 most common frequency distribution shapes. I want you to be able to recognize those shapes and understand the effect that they have on our measures of center. The most common, we have a symmetric distribution. I can draw a line straight down the middle, and it's a mirror image on both sides. The one shown here is our standard bell curve, but it doesn't have to be a bell curve to be symmetric. It just means we can split it down the middle, and it's the same. Okay? But this is our standard bell curve distribution that we'll be dealing with a lot. Okay? When we have a symmetric distribution, mean, median, and mode are going to be very, very close together. Okay? At least definitely mean and median. Mode, sometimes if we have a bimodal, it might be a little bit different. Now, no data is going to be perfectly symmetrical, so they're not always going to be exactly the same, but they should be close together when we have a symmetric distribution. If we have a uniform distribution, it means everything's the same. Meaning we're not going to have a mode, or at least one that's meaningful in any way. And then our mean and median should be in the middle again. Our uniform distributions are also symmetric. So it's an example of another type of symmetric distribution. And then we have skewed left and skewed right. When we have skewed data, it creates a tail in the direction of the skew. All right, and elongates it in that direction. And so when I look at this first data, the bulk of my data is up here, but then because I have this trailing end, I have this longer tail on the left. And that tail pulls the median and the mean in that direction. So if we're skewed left, our mean is going to be less than our median. And our median is going to be less than our mode. So that skew is going to pull those values further to the left. While a skew to the right, it's elongated on the right-hand side, pulling our mean and our median further to the right of the center of our data. Okay? So the mean will be moved to the right of the median versus the mean moved to the left in the direction of the skew. So being able to look at any of the distribution shapes and get an idea for the relative positions of mean and median and mode.